So hi everyone, how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel of Unacademy, all the concepts of physics, chemistry, and maths are being taught to you completely in English. This is the series that I host for class 12 students, those who are looking to take their JEE in the next month. And this is a quick review series where we are going quickly over the key concepts or related to any topics, and then we are also discussing a bit of problem solving. Okay, so this is part 7 of thermodynamics. Now before we get started with today's discussion, let me introduce myself for those of you who don't know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi, and for almost past 8 years now I've been teaching physics for the IIT JEE examinations in the offline setups. Now offline I've been associated with some of the topmost institutes that you guys know of. And I myself, as a student, was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. I also qualified in the NTC stage 2, and I was in the top 1% in the NACP. I've already coached many students to top ranks in IIT JEEs in the offline setups, and now I hope to continue doing that here online with you guys. So the last year and this new situation has forced all of us to adapt. So I had to move online. So that is one great option for you students also who are worried about how your preparations are going to go ahead in this lockdown period and where no offline coachings are available. So hello AP, how are you? So this is one great way to ensure that your studies are going ahead uninterrupted. So what you can do is you can get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis, and then you also have live quotes and leaderboards in these classrooms, which keep them highly interactive and very much fun. You also have test series and analysis sessions happening on regular basis, which will ensure that your studies are going on smoothly. Okay, and of course, you have live doubt clearing sessions. So again, for all the Unacademy Plus courses, this is a feature that will compulsorily help you. Okay, so after every 3 teaching sessions, all the Unacademy Plus courses have to have a live doubt clearing session. So an entire session dedicated completely to your doubts. Okay. Okay, so features like that will ensure that your doubts never get piled up and you are having a smooth go for your preparation. Okay. Next, of course, uh, you also get the opportunity to study from the topmost educators all across the country from the comfort and safety of your home. Okay, so I think that's another wonderful feature that you can avail from here. All right. So how do you ensure that you are getting all these benefits and you are going ahead with your preparation? So the first step towards that is getting yourself the Unacademy subscription. Okay, so the first step is to install the app. The moment you do that, you unlock for yourself a lot of features. So including there are a lot of free courses that are running on the Unacademy app. Now to enroll in those, all you need to do is just install the app. You don't even have to take a subscription. Then there are special classes happening on a regular basis. So I myself usually take 3 special classes in a week, which are absolutely free of cost. So there we keep special agendas. Okay, so those again you can join just by installing the app. And of course, there are quizzes happening on the app which you can take part. Okay, so all these free features you can unlock simply by installing the app and using the code RD Live. You can use this code RD Live to unlock all these wonderful free features. Okay, now that will give you a flavor of how your plus subscription experience is going to be, and if you are convinced and if you finally decide to go ahead and get yourself that plus subscription, then this is how you should go about it. So you can go to the plus section of your app and then select your goal as IIT JEE and click on that get subscription button. Now the moment you do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? So don't forget to use this code RD Live in that box. You can put this code there, and this code will give you a 10% off on all your subscription fees. Okay. Now you can choose from 2 subscriptions plus an iconic, and the fees of both the subscriptions are laid down there for you to see. Okay, so these are the costs for 6 month subscriptions. This are the costs for 1 year subscriptions, and these are for the 2 year subscription. Okay. Now you will also realize when you click on proceed to pay, you get a lot of no cost EMI options to choose from, so that all these payment options also do not become a burden for you, and you can choose a convenient payment plan for making these payments. Okay, so getting this subscription is super easy. Okay, now let me just tell you about the iconic subscription bit. So the iconic subscription is something that will take your IIT JEE preparation to the next level with personal coaches. Okay, so with this subscription, you get allotted personal coaches from our team of experts who will personally guide you and closely mentor your performance throughout your IIT JEE journey. You'll also be able to attend a lot of IIT JEE workshops, receive timely expert guidelines, get a study planner, and have test and analysis sessions. So all these wonderful, wonderful features will make sure that you sail through your IIT JEE journey board. Okay. Next, now, if you're looking for a single stop solution for all your studies, be it about IIT, be it about your boards, 11th and 12th, so you can go for combo subscriptions. So there are currently 4 combo subscriptions available. First subscription is the iconic subscription for JEE and the plus subscription for 11th and 12th. Okay, then you have a combo subscription where you get iconic for all 3 of them. Now the costs are as shown here. Then you can go for a combo where you get all 3 plus, or plus for JEE and iconic for your 11th and 12th. So again, the fees are here mentioned on the side. Okay, so you can go for a combo subscription and leave all your worries about everything related to 11th, 12th, be it your boards, be it your school examinations, be it your IIT JEE Mains, IIT JEE Advanced, all everything will be taken care of with the help of these combo subscriptions. Now, these are the upcoming tests in January, so please pay close attention. There is the Unacademy Combat, which is going to happen on the 17th Jan and the 31st of Jan. Then there is a race test that is going to happen on the 10th of Jan and the 24th of Jan. Then Last Mile Target 2021 already happened here. Okay, then you have AIM Advanced, which happens every Saturday, and you have unique DPPs, which are covered every Monday to Thursday. So make sure you're not missing out on these also. And finally, for those of you who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using that link, so that you are getting all the timely notifications of all the sessions and lectures happening here on this particular channel of YouTube. All right. So with all that information given, let's get back to the discussion of the day. Okay, so let's see what Arjun has to say. So Arjun says, sir, my physics teacher at school was like, from modern physics, you can't expect many questions. So focus on thermodynamics. So I checked that 41-year book, and while are 77 questions in 16 papers. Yes. In fact, ARJ, off late, IIT JEE, I think, let's say in the last 10 years at least, they have asked a lot of questions from modern. Okay, maybe earlier, up to early 2000s, they never used to ask a lot of questions from modern. Very few, if you see. But from the last 10 to 15 years at least, they have been focusing a lot on modern physics as well. So modern physics, in fact, has become very significant. You should not be leaving that out. Okay. So that is why you need to seek a guidance from the right experts. Okay. All right. So no, never. Don't even think about leaving out modern. Okay. All right. So getting started with today's topic. Last class we talked about conduction. Today we will talk about radiation. So thermal radiation obviously is the electromagnetic radiation generated by thermal motion or agitation of particles in every matter. Okay. Now, all matter with a temperature greater than absolute zero will emit some kind of thermal radiations, and this results from charge acceleration or dipole oscillation that produces EM waves. So in most of your substances, things are made up of dipoles, small dipoles. So when at any temperature, that these will always oscillate about their mean position, or they would be moving here and there. So they are constantly accelerating. Okay, and that constantly accelerating or accelerating charged particles will emit EM waves. So that is the phenomena of electromagnetic radiation. Okay, so every particle, because of its motion and its acceleration, will emit some kind of EM waves. Okay, Next, in radiation, the transfer of heat takes place from one place to another without heating the intervening medium. So the EM waves that are emitted, obviously they do not heat the medium unless the medium is interacting with them. So if body A is emitting waves which are being emitted, collected by body B, so the heat is directly transferred from A to B without the medium itself getting involved. Okay. Now let's quickly talk about the properties of radiations. Now radiant energy travels in straight lines. Also, radiation is a surface phenomena. Please remember that all radiation happens from the outer surface only. So there is no radiation happening within the volume of any solid. Okay. Now, all radiations can be reflected and refracted or even interfered. So these are electromagnetic waves. So they will show all the properties that light waves will show. Okay. Now they can obviously travel in vacuum. You know that we get this heat from sun, okay, and we have huge space of vacuum between us and the sun, okay. So obviously it's those electromagnetic waves that are traveling through this vacuum, and also the intensity of the radiation follows inverse square law. So the farther you are from the sun, the colder you are. You would know that planets which are very far away from the sun are way colder, okay, and the planets which are closer to the sun are hotter, obviously. So that is because this radiation intensity will fall over a distance with inverse square law. Okay, thermal radiation can also be polarized exactly the same way as light, again because these are EM waves, so you can polarize them also. All right, now let's go over some basic definitions. Okay, so first we'll talk about energy density. So any radiation that is traveling from one place to another obviously is carrying some energy. So energy density obviously is defined as the total energy per unit volume at any point in space. Okay. Now it is for all kinds of wavelengths. Okay. So if suppose sun is emitting rays, so sun is emitting rays practically ranging from all possible wavelengths from zero to infinity. Okay. So it is the energy associated with all those wavelengths at any point in space per unit volume. That is what we call energy density. Then you have spectral energy density. Spectral energy density refers to the energy corresponding to a particular wavelength. Okay, and obviously the total energy density would be related to the spectral energy density by this relation. Next, you have emissive power. So the amount of heat radiated per unit area of a surface per unit time is obviously called the emissive power of the substance. Okay, so these are the basic definitions. I'm just going over them quickly because I expect you to know them already. Okay, this is a quick review. Then you have spectral emissive power. Spectral emissive power, of course, refers to the emissive power corresponding to a particular wavelength. Okay. Now, whenever any radiation is incident upon any surface, now there are three possibilities that can happen. Okay, so suppose you have a surface here, and there is a radiation that gets incident on it, right? So some part of it may get reflected. Okay, some part may get absorbed, and some part may get transmitted across the medium. There are three possibilities that will happen. Okay, some part is getting transmitted, and some part is getting absorbed and lost. Okay, so there are three possibilities. Now, the fraction of the incident energy that gets reflected is called the reflectivity or a reflective coefficient. Okay, so this is the amount of heat reflected or energy reflected over the incident energy. Similarly, the absorptive coefficient or absorptivity is the ratio of the amount of heat absorbed is to incident amount of heat. Okay. Next, you have transmittivity. So this is the ratio of the energy transmitted to the incident energy. Now you will realize that the sum of all these three coefficients for any object will be equal to 1. Okay. All right. So let's try this one. So you've been told that total radiations incident on a body is 400 joules. Okay. If 20% radiation is reflected and 120 joules is absorbed, then find out the transmittivity of the body. Okay. Try this very quickly. So hurry up. See if you can figure this out. So you've been told that 20% of the radiation is reflected, 120 joules is absorbed. What is the transmittivity? Try this, and answer quickly. So till the time you guys try and figure this out, let me have some water. Okay, AP says 0.5. Let's see. So I told you there is three possibilities, right? So I've been told that Q incident is 400 joules. Incident is 400 joules. Now Q reflected is 20% of Q incident, right? That is 20 over 100. Reflected would be 20 over 100 into 400. So that is 80 joules. Now I also know Q absorbed is 120. So rest of the energy must be getting transmitted. So Q transmitted obviously comes out to be 400 minus 80 minus 120. That is 200 joules. So 200 joules of energy is getting transmitted. So obviously transmittivity is Q transmitted over Q incident. That will be 0.5 indeed. Well done, AP. That is the right answer. Okay. All right. Next, we define something which is called a perfect black body. So for any body surface which absorbs all the incident thermal radiations at low temperatures in irrespective of their wavelengths and emits all the absorbed radiations at high temperatures is assumed to be an ideal black body. Okay, so an ideal black body has two kind of characteristics. One, it can absorb all the wavelengths incident on it, so it has absorptivity one, and then it can emit all possible wavelengths at high temperatures also. Now, the nature of the emitted radiation from an surface of an ideal black body will only depend on the temperature. Okay, then an ideal black body need not be black in color. Okay, so that is a common misconception. Example, sun is also treated as a completely black body. Okay, so hi Rajesh, hello Aftab, how are you guys? Okay, Shivam, that's all right. That's all right. You can watch the recorded session. Okay. Okay. Now we will define something called emissivity. Okay. So at any given temperature, a perfect black body has the highest emissive power. Turns out compared to all other bodies, okay, of identical surface areas. So what emissivity is? It is the ratio of the emissive power of any body to the emissive power of the perfectly black body at the same temperature of the same area. Okay. So hello Aditya. Yes, 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 Rajesh. We discussed that. Okay. Yes, you are correct. That is the right answer. Okay, so that is how you define emissive power. Sorry, emissivity. Emissivity is the emissive power of any body to the identical black body at the same temperature. Okay. Next, we'll talk about Kirchhoff's law quickly. So this law says, according to this law, the ratio of the emissive power or to the absorptivity is same for all surfaces at the same temperature and is equal to the emissive power of a black body at that temperature. So this is what this law says. It says if a body has emissive power E1 and absorptivity A1, and another body has an emissive power E2 and absorptivity A2, then E1 over A1 is equal to E2 over A2 is equal to emissive power of a black body over absorptivity of the black body, by the way. Absorptivity of the black body is 1, so that is why you have this. Similarly, you can have it for spectral thing also. For a particular wavelength, you will have this ratio. Okay. What this implies is that you realize if you rearrange the coefficients, in other words, this law says that good absorbers are good emitters. So this is a statement that you must remember because they have asked direct questions from this statement. Okay, you realize if you rearrange the coefficients, that is what you get, right? And this by definition was E. So this law, Kirchhoff's law, says E equals A. So the emissivity of any body numerically is always equal to its absorptivity. Hence, any body that absorbs well will emit well also. Okay. Okay. Next, we will talk about Stephen's law of radiation, okay, or universal law of radiation. This is again a very important topic that we need to cover. So this law says that the amount of radiation emitted per second per unit area by a perfectly black body is proportional to the fourth power of its absolute temperature. Now, please note that Stephen's law was defined only for a perfectly black body. Okay, so it says amount of radiation emitted per second per unit area by a black body is proportional to the fourth power of the absolute temperature. This is the equation. It says E equals sigma to the power into t to the power 4, where sigma is the proportionality constant and is known as Stephen's constant. Its value is 5.67 into 10 to the power minus 8 in SI units. Now, for any surface with emissive power, emissivity E, the energy radiated per unit time per unit area would be this. So you realize the power can be written like this. It will be sigma times area times emissivity times t to the power 4. Okay. Good evening, Mahi. How are you? All right, why don't we try a problem with this? So here you've been told an operating temperature of the tungsten filament in an incandescent lamp is 2000 Kelvin. Okay. So you have to find its emissivity. If its emissivity is zero point 0.3, you have to find the surface area of the filament. Okay. So power of the lamp has been given to you. Okay, and other data has been given to you. You have to find the surface area of the filament. So try this quickly. So how do you think you will approach this? Again, let me tell you a small hint here. Use this formula. You can use this formula. Power emitted by any body is equal to sigma A e to the power t to the power 4. So you have all the data here except for area. Okay, just substitute all the values and you will simply find. Okay, so let's just do this. So I know that P equals sigma A e power 4. So obviously area would be P over sigma. That's it. That's it. You just substitute the values and find out what the answer is. Power I know is 25 watt. 25 over sigma is 5.67 into 10 to the power of minus 8. And the temperature is 2000 and emissivity is 2000 to the power 4. This is what you need to do. Okay, just find out the value and that will be the answer. Okay. This is a fairly simple question. Okay. All right. Now let's talk about another problem. So you've been told a perfect black body, black sphere radiates energy at 900 watt. If the radius of the sphere is halved and the temperature is doubled, then what will be the new radiating power of the sphere? Okay. So again, this is the question that had been asked in advance, I think. This is a advanced PYQ. So very simple. Very simple question. Okay, so quickly try. Let's see. That is the answer that you're getting. Hello, Manoj Kumar. How are you? Okay. So I hope you guys have figured out the answer. So try and answer this quick. This is an easy question. Come on, people. So hurry up a bit. Let's try and answer this very quickly then. What has been asked to you? You've been asked the radiating power. Again, use the last formula B. Okay. Okay. AP also says B. Yes. You just studied that the radiating power is A sigma T to the power 4. Now you've been told that the radius is doubled. So radius is doubled. Radius is halved. Temperature is doubled. So for P dash, We've been told area would become 4a, okay, a by 4, sorry, a by 4, because if you uh, reduce the radius to half, then the area would be reduced by 1 by 4. Okay, what am I saying? 1 by 4. Similarly, T dash has been told to you as 2T. Temperature has been doubled. So obviously, what will happen to the new power? P dash would be equal to A by 4 sigma to 2 to the power 4 times T to the power 4. So I can say that P dash would be nothing but 4 times P. 4 times P will give me 3600 as the answer, which is the correct answer. Okay, well done, people. Well done, Tanya. Well done, AP. All right, now try one more problem. So here you've been asked that a spherical body of area A and emissivity zero point 0.6 is kept inside another perfectly black body. Total heat radiated by the body at temperature T is. Okay, again, this is also an advanced PYQ if I remember. So try and give me the answer very. This is very simple, huh? Let's get this right very quick. Okay. Okay, if you think. See. Anybody else? So what do you think is the difference with this? What difference does this make? If it wasn't kept inside a perfectly black body, then what would have been the case? Any ideas? Think about this. Okay. So basically, the perfectly black surroundings are ensuring that all the rays emitted by the spherical body are being absorbed, and none of them are getting reflected back. Okay, so yes, this is the correct answer. Okay, well as that. Okay. Next, let's go over the Wien's displacement law very quickly. So Wien's law corresponds to the maximum emission radiation. It says that decreases that the lambda corresponding to the maximum emission decreases inversely with temperature. Okay, so if this is the graph where you have spectral radiation intensities with respect to the lambda, you will realize so the entire spectrum of emissive power is spread over across all the wavelengths theoretically from 0 to infinity. What happens for a black body? Okay. However, there is one particular lambda for which the spectrum emission is highest. Okay. Now, if you realize that if you increase the temperature, that lambda corresponding to that peak value goes on decreasing. This is what this law tells you. Okay. So here you will realize that for T1, the peak is lying here. For T2 is higher than this. Okay, and if T3 is higher than this, then you realize this is what's happening. Now, why is the area under the graph increasing? Because the total emissive power is increasing. Okay? Here again, the wavelength corresponding, as I said. So, what I am implying is that lambda corresponding to the maximum amount of emissive power is inversely proportional to time, temperature, sorry, which tells me that if I introduce a proportionality constant, then I have this expression lambda m times t equals b, where b is a constant which is known as Wien's constant, and the value of this constant is this. Again, you can memorize this. Again, this is the value for a perfectly black body. Okay. Now let's talk about questions that have been asked on this topic. We've been told that the temperature of a furnace is 2000 degrees Celsius. In its spectrum, the maximum intensity is obtained at 4000 angstrom. If the maximum intensity is at a 2000 angstrom, you have to calculate the temperature of the furnace in degrees Celsius. At what temperature would the maximum intensity obtained would be at a 200 angstrom equivalent? That is what you have to find. Okay, think about this. Easy, super easy. So hurry up. Let's see. Hmm. Okay. Okay, enough time. I think this is an easy one. You guys shouldn't be taking this long. Okay, hurry up. Question doesn't even deserve this much of time. Okay. Okay. Somebody is trying it. Always good to know. Okay. Now that is one thing that I wanted to tell you. That even if the temperature is given in degrees Celsius and is asked in degrees Celsius, the temperature that you're using in Wien's law equation, lambda into T equals B. So this is absolute temperature. Just remember that and you'll be fine. So you realize if the intensity is getting halved, so the temperature will be getting doubled. So I can say since lambda dash equals lambda by 2, T dash must 2 times T would be 2 times 2000 plus 273. Okay, and then minus 270 you have to do. Okay, turns out the answer would be 4273. Okay, well done again, guys. So again, a common mistake is that the people would report the answer as 4000 degrees Celsius. Oh, okay. Always use absolute temperature in this formula. Okay. All right. Again, you have another question which says three discs A, B, and C of radii 4, 6, 2, 4, and 6, respectively, are coated with carbon black. Now, the wavelengths corresponding to maximum intensity of the three discs is 300, 400, and 900 nanometer, respectively. QA, QB, QC are the powers emitted by the ABC disk. Then, what is the relation between the powers emitted by different disks? That is what you have to find. Think about this. Think about this. So, how do you do this? Let's see. Any answers again? This is very easy. Okay. Okay. So AP says B. So let the radii of A, B, C, D कुछ कुछ रख देते हैं 2 आवर 3 आवर एंड देखो दिया ही है 2. Okay, these radii are 2, 4, and 6. Right. Next, what you have been told is that the maximum intensities are of the ratio of this. Now you know from Wien's law that lambda 1 is to lambda 2 is to lambda 3. That would be 1 over T1 plus 1 over T2 plus 1 over T3. Right? Right. So what I can say is, so I get a relation between the temperatures. Okay. So if I assume, okay, this is equal to this is equal to 3 is to 4 is to 5. Right. That is what I can conclude from the given data. Okay. If there's any problem. So now, if I assume that, so what we are going to do is we are going to just see what the ratios are. So here you have the temperature. You also have the radii. You know power is sigma e a t to the power 4. So that is what you're going to use. Okay, that is what you will have to use. So now I can say is, so if I talk about QA कितना होगा भाई? Q would have been sigma e, A1 would have been pi into 0.2, or 2 into 10 to the power minus 2 square or minus 4 and 2 t of 1. Now t of 1, if I imagine that that is some, say, t by 3, let t a be t by 3, t b be t by 4, and t c be t by 500. 5. Now you realize the ratio of some t by 4 and some t by 5. Now you realize that the inverse ratio would be of 3 is to 4 is to 5, correct? And all you need to do is calculate the individual powers and compare them. So QA. So I've been told that all of them will behave like perfectly black bodies. Okay, so this QA becomes sigma by 4 into by 3. Right. So what about QB? QB similarly can be found by using the expression sigma 2 pi into 4 to the power minus 3 into the temperature of is to the power 4. And 5. So here it will be 4 square. Okay. So again, if you compare these, what you will realize is that B in fact does have the maximum intensity power emitted. Okay. So that is the correct answer, guys. Congratulations, well done. All right. Now we will talk about rate of cooling. Now we realize at any body at any temperature not only radiates energy but also absorbs radiations on them. Okay. So what you do is you already know the amount of energy radiated. So dq over out. The energy that is getting radiated is sigma E A T R of 4. Now, Q incident, the amount of heat incident on this body per unit time would be sigma A T surrounding to the power 4. Okay. Why? Because surroundings behave as perfectly black bodies, so they will emit every black body, every radiation, and for them the emissivity can be considered to be 1. Okay, now the net loss, the Q net by dt, so that will be, take the minus a a common, then you have p to the power 4 minus t. Now, why do I have E here? Because the amount of energy incident, this is incident, is this, the amount of energy absorbed would be E times this. Okay, so that is what you get. Okay, now what you can do is again you will realize also Q net will be equal to M S d theta or dt. So if I substitute that here, then what I get is dt over dt equal to minus sigma over times E over m times s t power 4 minus t s to the power 4. Okay. This is what you call rate of cooling. This is the amount at which the temperature of the body is dropping. Okay. Please note that. Now we'll talk about Newton's law of cooling. Now, according to this law, when a small temperature difference between the two objects and its surrounding happens, then the surrounding, uh, then the rate of cooling of any object is directly proportional to the difference in temperature from the object and the surroundings. So this is an approximation of the last result. Oh, the approximation of the last result. Okay. Now, what you will also realize is that this law, Newton's law, says that minus dt over dt is directly proportional to the uh, temperature difference between the object and the surroundings. Now, if you introduce a proportionality constant, okay, so what you can say is that if you integrate this, then this is what you will get. This is the rate of cooling, and there is change. This is can be assumed to be proportional to the difference in the average temperature of the body and the temperature of the surroundings. Okay, now that the law of cooling under approximation. Again, approximation required for this is that this temperature difference. Okay, or rather this is an approximation again. So though the actual formula is this, if I introduce a proportionality constant, the actual graph will be like this. But I sometimes like to use an approximation. That is what we do. So if I have to find the rate of cooling between, let's say, this point and this point. Okay, so imagine here the temperature of the body is T1, here the temperature of the body is T2. So from here to here, I can say that the average temperature is nothing but T1 plus T2 by 2. Now the rate of cooling, which is delta T over delta T, can be often written as constant, okay, alpha times T average S T of surround. That is what I'm doing. I have told you that. Okay, I hope I will be followed this. Now let's try a question from Newton's law. Again, wherever possible, use the approximation method. Okay, you've been told if a liquid takes 30 seconds in cooling from 80 degrees Celsius to 70 degree and 70 seconds in cooling from 50 to 60, 60 to 50. Find out the room temperature. So try this. So again, use the approximate formula, okay, and get your answer. So okay, let me just say. So when it moves from 80 to 70, so you realize here T1 average. The average temperature, I can say that that is 75 degrees. Here to here, let's call this T2 average will be equal to 55. Okay. Now here you don't have to worry about converting this temperature into absolute, because the difference into temperatures remains the same in the Celsius scale and the absolute scale. That is why you do not need to bother about that. So now you can say it got the temperature got reduced by 10 degrees Celsius in the 30 seconds. So rate of cooling delta V1 over delta T1 to be equal to average 1. Okay. So same equation we will get for the second object also. So you have been told that for the first it is 10 by 30, and that would be equal to the P average 1. P average 1 was 75 as T surrounding times K, right? And for the second case, what I can see is that again the temperature dropped by 10 degree, but that happened in 70 seconds. So the rate of cooling second case is this. This should be equal to 55 minus T surrounding time. Okay, because the average temperature for the second time was 55. Now all you need to do is divide these two equations. Let's see. We will get rid of the K. That getting 7 by 3 plus 75 S over 5 minus. Okay. Now you can solve this and find the value. Okay. All right. Let's try one more then. Now a body cools in 10 minutes from 40 degrees to 60 degrees. Okay, sorry, the other way around. From 60 to 40, it cools in 10 minutes. So, what will be the temperature in the next 10 minutes if the temperature of the surroundings is 10 degrees Celsius? Again, use the approximation of the average temperature. Okay. Yeah, hurry up, hurry up. Let's try this. So, let me just do this. So, you know that delta T, which is 20 over 10, would be equal to the average would be 50. Okay. Yeah, that is. Similarly, second for the second case, I will realize that I don't know what the temperature is. So let's say the temperature is T. So initial temperature would have been 40, right? T minus X over, okay, what's the time? 10 minutes. This should be equal to, okay, I don't know where. So what we can do is that we can assume the final temperature to be some T. Then the average temperature would be T plus 40 by 2 minus T. Again, all you need to do is divide equation 1 by 2. Divide both of them, get rid of K, and you. Okay, I hope you guys are following these steps. All right, surprisingly enough, that is it for today. So we have wrapped up the entire radiation very very quickly. So I hope you guys got a quick review of all your theory and got some good practice with your questions also. So that is where I would like to wrap up thermodynamics. And next we will start the topic of SHM and waves. Okay, so do remember to join me for that. Okay, and practice some more of these questions because this is one very important topic. Okay. All right. So with that, let's bring our session for the day to an end. Okay, and before I leave you, let me remind you that this is how you can get your plus subscriptions if you're planning to get them. Okay. So first, you need to go to the plus section of the app. Then you select your goal as IIT JEE, and then you click on that get subscription button. Now, when you do all that, you will be redirected to the payment page where you can use this code RD Live in the box that says, "Do you have a code?" And this code will give you a 10% off on all your subscriptions. Okay, now you can choose from two kinds of subscriptions, plus an iconic with the fees laid down before you. And also, when you click on proceed to pay, you can select a lot of options from no cost EMI options available to ease that payment for you. Okay. Now you can also go for a new subscription that Unacademy has to offer, which is the iconic subscription. Okay. So this subscription will take your IIT JEE preparation to the next level by allotting personal coaches to you from a team of experts and also giving you the extra benefits. Okay. Now you can also go for a combo subscription, which gives you a single stop solution for all your study worries if you are coming to class 11th now. Okay, so what all worries you? So your class 11th boards, your class 11 school examinations, your CBSE studies, class 12 boards, again your CBSE studies, your IIT JEE Mains, your IIT JEE Advanced. So all these worries would be taken care of with the help of this subscription. So this is a combo subscription which gives you subscriptions for all. Now you can get different kinds of combos. So the first combo has the advanced subscription for the IIT JEE preparation and the plus subscription for the 11th and 12th subscription. And this combo starts at this price. Next, you can go for a combo which gives you an iconic subscription for all three. Okay, so for IIT JEE and your 11th 12th CBSE, this combo starts at 500 a month. Then you could have gone for a plus combo for all the three. This combo again goes for comes for around cost around 3,000 a month. And finally, you can have a combo where you get IIT JEE plus subscription and iconic 11th and 12th subscription. So this combo costs you around 900 a month. So again, suit a combo that makes you feel more and more comfortable. And trust me, with these combos, all your studies for the next 2 years will be taken care of. You don't have to worry about it. Right now, it's time that I announce the upcoming test in January. So there is Unacademy Combat, which is going to happen next on the 17th of Jan and the 31st of Jan. Then you have a race exam, which is going to happen on the 10th of Jan and the 24th of Jan. Then last mile, which is target 2021, happening on the 9th Jan. Okay, already happened. Then you have AIM Advanced 2021, which happens every Saturday. And finally, you have unique DPPs, which are happening being discussed from every Monday to Thursday. Make sure that you're taking part in these and benefiting out of these. Okay, don't miss out on any of these. These are all very important events. Okay. Now, if you like today's video, then don't forget to press the like button and share it with more and more people. I keep telling you this. I can't insist enough on this. So there is a reason that we are providing you free quality content that is for all the students who can't afford these subscriptions. So trust me, it becomes your duty to share it with more and more people so that more and more people get to get this quality knowledge free of cost. Okay. If you're new to the channel, don't forget to subscribe. Okay, to the channel and don't forget to press the bell icon. Okay. Now the PDF of all the slides used in today's lecture would be available for download very soon. Next, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So don't forget to connect with us on the Telegram app using this link. So this will ensure, see, that you're getting all the notifications of all the lectures and sessions happening here very, very timely so that you're not missing out on any of the amazing content being given here completely free of cost. Okay. Next, before I take your leave, one last time, let me just remind you that this is my code RD Live. Okay, you can use this code to get your Unacademy subscriptions. If you're planning to get them anytime soon, okay. And this code will obviously give you a 10% off, of course, all your subscription fees. So if you like my lectures, if you like to enroll in my courses, this is what you do. You can delegate your subscription to me by using the code RD Live. Okay, so that is it. That is it. That is where we would conclude today's session. Next Friday, we will start with the next topic, which is SHM and waves, which is the last topic of class 11th, I think. So with that, our entire review of class 11th will be over. So I'll see you on the next Friday. Till then, you guys keep practicing hard and keep studying hard and take good care of yourselves. Bye bye.